We continue with the rebuttal of the evidence of evolution. In this video, we're looking at biogeography and homologous structures. So biogeography basically looks at the distribution of organisms on different continents, and it links with the concept of continental drift, that all of the continents were initially fused together, and then we had continental drift where it drifted into two supercontinents. On the top, you had Laurasia, and at the bottom, Gondwanaland, and those separated into the continents that we have currently. Right. So if you search up biogeography, one form of biogeography, you'll get something like this. You're looking at the fossil remains of certain organisms that are found in different continents. Right. So that wouldn't show evolution. What it would show is that it would be evidence of continental drift and showing that those fossils were found in different continents. Okay, so there are certain organisms that are found currently living extant, not extinct, that are found in different continents. Some of them are found in different continents because humans have introduced them, but others that have a significant means of dispersal are found in different continents as well. And that's naturally found in more than one continent, although they are few. Now, more often when we're looking at evolution, the changes in species linked to this, they're looking at those that are extant, living organisms in different continents that are somewhat similar, right? So if you look at these two species of camels and the llama, they found on different continents. And what they're saying is that because they show similarity in their features, then there's a probability that they had the same ancestor when the continents were fused, and when it got separated, that ancestor then went through speciation and changed to form these different forms. Now, this, while it's being used as evidence of evolution, actually it requires evidence itself, because if we look here, this doesn't show that they've originated from the same species. It's an assumption that the ancestor, a common ancestor, was found on the fused land, and then it separated, and then they changed to form these different species now, right? And they look similar because they had the same ancestor, right? So it's not an evidence. You require evidence in order to prove that assumption. It's just an assumption. But other examples they give is that of those flightless birds, like you've got the ostrich in Africa, you've got the emu in Australia, you've got the rhea bird in South America, and they use a similar example of the of biogeography to say that they found in different continents and they come from the same ancestor. But again, you cannot prove that they've come from the same ancestor. That's an assumption, and it requires evidence to prove that also. So while they're saying biogeography is an evidence of evolution itself, it requires further evidence. It's just an assumption that this is how they could have come about. Another evidence of evolution is homologous structures. So homo coming from the word same, to say that there's a similar formation of structures. So if you look at the organs, the limbs of the body in a human, if you look here at the arm, you've got the humerus, ulna and radius, the carpals, and then the phalanges, which are making up 5 digits. If you look at the dog, you also got 1 bone, and then 2 bones shown in red and beige. Then you've got the yellow, and then you've got also around 5 digits in a bird, 1, 2, and then you don't have 5, is around 3 digits here. And in a whale's flipper, you'll find that it's got 1 bone, 2 bones, although all of these are fused, they're not separated like the radius and ulna here. All of these are fused together, and there's no flexibility at that joint normally. And then you've got, again, 5 digits. So what they're saying is, because all of these have 1 bone, then 2 bone, and then even though the number of phalanges are different if you count them, but saying that it's made up of 5 digits in some of them, then they're saying that the fact that they all have this arrangement, they all have received it from a common ancestor, that they've got common ancestry. Now, again, that is used as evidence, one form of evidence of evolution. It's how they're classifying this. But again, does this show that they definitely had a common ancestor? No, right? And you can't just look at one limb and make, it's basically an assumption, and they're using assumptions as evidence. Now, if we take another limb, let's take the same organisms and let's look at their jaws, for example. So if we take a human versus a dog versus a bird versus a whale, we find a very different dentition, where the human dental formula is 2123 over 2123, two incisors, one canine, two premolars, and three molars. That's for half of the upper jaw and half of the lower jaw at the bottom. If you look at a dog, we've got a completely different dental formula with three incisors and four premolars and two molars on the top and three molars at the bottom. Right, so there's a different arrangement of the number of bones that of teeth rather that are found here. If you look at birds, don't even have teeth. And then if you look at something like whales, certain whales don't have teeth at all. Certain whales have one or two teeth. Certain ones have up to 240 teeth. So someone could then look at this arrangement of these structures and say, because they've all got completely different arrangements of the teeth or their mouth structures, and therefore I can come to the conclusion that all of these don't share a common ancestor and they are all coming from different origins. Now, the same organisms, looking at different parts of the body, you can come to completely different conclusions. So again, this cannot be in any way convincing evidence to say that these organisms have come from the same organism. In the next video, we'll be looking at genetic evidence and the rebuttal of the genetic evidence that is proposed as evidence for evolution.